Welcome to the Explainer. If you've been working with AI agents in TypeScript, you absolutely know that getting them to just play nice together is, well, often the hardest part of the entire job. So today, we're diving into a framework that completely flips traditional multi-agent architecture right on its head. The plumbing ends up bigger than the actual logic. This is a quote from an excellent architectural breakdown over on Dudarik.com. And honestly, if you've tried to coordinate multiple LLM agents around a single shared goal, you have felt this exact pain. You know how it goes. You sit down to write some really cool AI logic, and suddenly you're drowning in managing agent context, manually wiring up graphs, and spending hours debugging why on earth your reviewer agent executed before the developer agent even finished writing the code. So we have to ask, why is coordinating AI agents such a mess in the first place? Well, current tools usually force you, the developer, to explicitly manage all the complex graph architecture. You're the one defining the nodes, the edges, the conditional routing, and the memory state transfers. Instead of focusing on the actual business goals of your application, you accidentally become, actually scratch that, you literally become a full-time graph traffic controller. Here is our roadmap for today. 1. The multi-agent plumbing problem. 2. Goal first, graph automatically. 3. Under the hood, task DAGs. 4. Supercharging agents with MCP. 5. How it compares. And finally, 6. Ready for production. Section 1, the multi-agent plumbing problem. The paradigm shift we're talking about today is massive. Think about the old way for a second. It requires you to manually wire the graphs, manage parallel execution yourself, and super carefully route context between steps. The open multi-agent way is entirely different. You and your engineers just describe the final goal and provide the team of agents. That's it. The framework handles the rest. It's a fundamental shift from imperative graph building to declarative goal setting. Section 2. Goal first, graph automatically. Now you might be wondering if this requires a bloated setup. No way. This incredibly powerful orchestration requires only 3 runtime dependencies. 3. It drops cleanly into any Node.js 18 or higher backend, and it's built natively for TypeScript 5.6. You aren't importing a massive ecosystem. You're bringing in a highly focused, lightweight orchestration engine. So, how do you actually use it? With one single, elegant function call, runTeam. You just pass it your array of agents, your team, and a string representing your goal. All the heavy lifting, from planning the steps to parallelizing independent tasks, all the way to synthesizing the final answer, is triggered by this single line of code. You describe what you want, not how to get there. Section 3. Under the hood, task DAGs. When you call runTeam, a very specific lifecycle kicks off. Step 1. The framework receives your goal input. Step 2. A dedicated coordinator agent analyzes that goal and decomposes it into a directed acyclic graph, or DAG, of tasks. Then, step 3 is where the real power unlocks: parallel task execution. The coordinator automatically identifies which tasks have absolutely no interdependencies and runs them at the exact same time. Finally, step 4 is result synthesis. The framework waits for the blockers to clear, finishes the dependent tasks, and compiles a final result for you. Of course, as developers, we never want to fly blind, right? Well, the framework provides an on-progress event that gives you streaming visibility into the entire process. It outputs events like agent start, task start, parallel runs, and task complete. You can watch right in real time as the coordinator decomposes the goal and kicks out independent tasks concurrently. You know exactly what is happening and exactly when. Section 4. Supercharging agents with MCP. A brain is pretty useless without hands. Out of the box, Open Multi-Agent gives your agents immediate grounding with 6 natively included tools. We are talking bash for shell commands, various file operations like read, write, and edit, plus grep and glob for searching. These basic capabilities mean your agents can immediately start interacting with the file system and executing commands. But, okay, here is the real aha moment for this framework: the Connect MCP Tools function. This feature allows you to attach any external model context protocol server directly to an agent's toolset, instantly. Want your agent to query a live Postgres database? Just connect an MCP server. Want it to automate a browser or search GitHub? Connect an MCP server. You don't have to write any custom adapters or complex integrations. You just attach the server, and your agent instantly understands how to use the specialized tools. It's a real game changer. Section 5. How it compares. To put this in perspective, if you're looking at LangGraph.js, you're looking at a graph-first, declarative philosophy. It's excellent if you have a fixed production topology and mature checkpointing needs. Mass draw, on the other hand, relies on an explicit supervisor pattern, which is great if you want to hand-wire your workflows and know every single step up front. But Open Multi-Agent sits in its own lane. It is a goal-first runtime DAG. It's absolutely best when you want TypeScript native automatic task decomposition. You don't want to enumerate every step, you just want the framework to figure out the graph dynamically at runtime. Section 6, ready for production. For those taking this to the real world, the framework includes critical, opt-in production controls. You get pluggable shared memory, so while it defaults to an in-process key-value store, you can easily swap in Redis or Postgres for distributed setups. You have context strategies like sliding window or compact to keep those input token sizes in check. You get task retries with exponential backoff for when API calls inevitably fail. And, crucially, a max token budget to hard cap your spend and protect your wallet from infinite agent loops just draining it dry. Now, it's important to know exactly what you're signing up for, so let's talk limitations. First, this is TypeScript and Node only. There's no Python support here. Second, the coordinator agent that plans the DAG consumes tokens itself, which might honestly be overkill for very simple two-step tasks. Third, while connecting MCP servers is easy, managing the lifecycle and health checks of those external MCP servers is entirely up to you. And finally, if you want that sweet auto-retrying structured output, you are required to use Zod schemas. We've seen how to completely eliminate the massive plumbing overhead of manual graph wiring. We've explored the power of runtime DAG decomposition, parallel execution, and those instant MCP integrations, all triggered by a single goal. So the question is, what goal will your multi-agent team accomplish today? Thank you so much for joining me for this explainer. Until next time, stay curious and keep building.